All right, you ready? What we're doing is we're going to solve for z. We're going to solve this equation for the variable. So if we're solving for z, the first thing we're going to do is we're going to divide by 5. We have to move everything over to the other side. All right, so what we have is now 10 to the z over 4. Equals 32 over 5. Now, I'm going to leave that as 32 over 5. That's a fraction that can't be reduced, right? Nothing goes into 32 and 5. There's no common factor. Okay, if you can reduce it, reduce it. Now, the question is, how do I get z by itself? I can see that right now z is being divided by 4. So that must mean eventually we're going to multiply by 4 to solve it, right? But not yet. Not yet. We have to think back when I talked about the relationship between exponentials. You don't need to write this little graph here, but this is an exponential curve, right? And then here was the logarithmic curve. These two things were reflected over this little line here, and this is a rough drawing, right? But that was the graph that I showed you. And that's because logs and exponentials are I'm waiting. Inverses. Very good. They're inverses. So when you solve equations, you use inverse operations, right? Use inverse operations. If an equation is like, hey, the square root of x equals 3, what do we do to both sides? We square both sides, right? We do the inverse. If an equation is 5x equals 100, what do we do to both sides of the equation? We divide by 5, right? If an equation is x plus 7 equals 43, we do the opposite. We do the inverse of adding 7, right? We subtract 7. This is how we solve equations. So the question is now, the question is, what is the inverse of base 10? Log base 10, right? And if you remember, we talked about log on your calculator, just log, is already base 10, right? We said there's a hidden little 10 here, like that. We don't have to write that little 10. Now, something I didn't do, if I do something to one side of an equation, what do I have to do? Yeah, I got to do the same thing on the other side. So I wrote that down wrong. It should be 32 over 5, but it should be the log of 32 over 5. Excuse my handwriting there. All right. Now, log and base 10 are inverses. So here's what happens. See ya. Imagine if I take away the base, right? They're gone, right? The base and the log are gone. That means the only thing left on the left side is this. What's the last step in solving this one? Because I have to isolate z. I have to do the inverse of dividing by 4. What do I have to do? I got to multiply by 4. So the last step is this. If I multiply both sides by 4, the 4 is gone on the left side. And this is what's left on the right side. So there are 2 boxes over here that we have to fill in with the answer. Right? For the first box, we're going to type in the equation that we just found. We're going to actually have to type this into con, okay? And then for the second part, we need the calculator answer. I need your guys' help with the calculator answer. Okay? Try it on your calculator right now. Make sure you can get the correct answer. 4 times the log of 32 over 5. If you're using the computer, you're going to have to say 32 divide 5. And then hit enter. And then hit log. And then hit times 4. What'd you get? 3.225. Okay, remember, that's because we're rounding to the nearest thousandth, right? The thousandth is the third place. All right, so let's review this. We solved this just like any other type of problem. We need to undo all of the operations. So the first thing was we need to get rid of the 5. We needed to divide by 5. Then we needed to get rid of this, the base 10. Whenever you see a base 10 up here, use regular log, right? Regular log on your calculator. Never use base 10. Sorry, see base 10, use regular log. Make sure you do that to both sides. And then undo whatever's left. If it's divide 4, you're going to have to multiply by 4, right? All right, now, here's the next one. Next one has a funky part to it that we've never seen before. Okay, if you look on your calculator right now, everybody look on the calculator. If you have the computer one, I want you to hit second. And then you should see a button on your calculator that has LN on it. Do you guys see that? So on the computer calculator, it'll look like this. Oh, it's down there at the bottom. Sorry, it's already down there. My fault. LN. Okay. LN is a special log. It's called the natural log. It's called the natural log because it is the inverse of a number which actually has a letter as its name. This is weird, right? Okay. Now, you don't have to write this part down, but pi is a number and it is a symbol, correct? So we don't, it's its own number, but we can't write out all the digits of pi, so we have a symbol for it, right? 3.14159, yada, yada, yada. Well, E is the same sort of thing. 2.71828 something or other, okay? If you don't really need to know exactly what that is, but if you wanted to on your calculator, you could say, what is E to the first? Or it's just right here. It says E right there. 2.718. There it is. Okay. E is a number. E is a number that was discovered by a guy named Euler. All right, so I want you to understand the background here. The guy's name was Euler. It's spelled like this. Spelled weird. Yeah. So Euler, not Euler, Euler, but he was Swiss French. It's kind of a weird name, right? Euler starts with an E. That's his name. It's Euler's number. We just say E. All right. The inverse of that, the inverse of E is natural log. So every exponential has an inverse, correct? So over here, I'm going to type this in. I'm going to say this is E to the X, like saying 2.718 to the X. That's all that means. And I'm going to say natural log. Look, inverses, aren't they? Inverses. The natural log's base is E. They are inverses of each other. Okay, so back to the question. We also say natural log. We don't say ln. It's called natural log, but originally it was French. So they would say logarithm de natural. I don't know if that's exactly it, but you could understand, like some languages say the descriptor after, right? Like Spanish does the same thing. So anyway, the whole point of it is right up here in the little note that I wrote. When base is E, use natural log. I see a base E right here. That means I'm going to use natural log to solve it instead of regular log. Okay? Let's do the first step, though. We aren't there yet. What's the first thing we should do? Yeah, get rid of that sucker right there. So now we have e to the 10t equals positive 6. The next thing to do is get rid of the e. What's the inverse of e? After that whole explanation, somebody please tell me what's the inverse of base e? Natural log. So I'm going to do natural log to both sides. Both sides. What happens here? See ya. So in all of your trips through the world of algebra and everything you guys have ever done, the only thing new in this whole sequence is the exponents, right? And getting rid of the base with the logs. It's still the same idea. We have to undo everything. What's the last step? Now I have to divide by 10, right? On the last question, we had to multiply, right? The last question was like this. It had z over 4 to begin with. This one is 10 times t. So we're going to have to divide like that. Notice this is not the natural log of 6 over 10. There's a difference between that, what I wrote, and this. This is not the same thing. This is not it, right? This is natural log of 6, and then divide by 10. So that's what we're going to put here. Somebody help me with the decimal form of the answer, pretty please. And you should check it yourself. Make sure you can do it right. Let's do it on here. If I'm using the computer, I'm going to say 6, and then natural log, and then I'm going to divide by 10. Then hit equals. We're going to the 1,000th. 0.179. Perfect. Okay, so there's 2 examples. I'll leave these up here for you guys, just like this. So you can come up here and view them on your own if you want. Okay, the notes are online. You can check them on Plainbook. Any questions? All righty.